Hello, everyone. Let's go ahead and get started on section 9.3, which is on polygons and perimeter. So as an overview, what do you call a parrot that flew away? A polygon. Wow. All right. So the word polygon comes from the Greek word polygonos, which means many angled. So polygons are essentially just shapes that have many angles versus things like triangles that only have three different angles. Polygons are going to be shapes with more than three, essentially, or just lots of angles. So things like we have like a starfish here, so angles in this case. We have some, looks like some yellow jackets or wasps that creating their nests in these hexagon shapes here. Then we also have a picture of the pentagon, which has five sides. So we have these different shapes with different numbers of sides, which also make different number of angles. So this is what we'll study today. So starting with polygons, say a polygon is a closed geometric figure whose sides are line segments and they're classified by the number of sides. So remember we said that closed meant that you could draw the entire thing without lifting your pen or pencil off the paper. So kind of a continuous type of shape here. And the sides are made of just line segments. They're classified by the number of sides they have. So starting off with the first polygon is the triangle. So a triangle has three sides. Here's what a triangle looks like. A quadrilateral has four sides. There's many different types of quadrilaterals. A pentagon has five sides. A hexagon has six sides. A heptagon has seven sides. An octagon has eight sides. A nonagon has nine sides. And a decagon has 10 sides. So you see, the more sides, the more angles that we create, they kind of get more circular as you go through here. So we have those basic examples. Some other examples is a dodecagon, which is 12 sides, and then there's an icosagon that has 20 sides. So we have different number of sides in this case to create different shapes. Remember the angles mean something as well. So we say the sum of the measures of the interior angles of a polygon with n number of sides is calculated with the formula n minus 2 times 180 degrees. So we can find the sum of the measures of any polygon in this case using this formula. So for an example, for triangles, we know that triangles are 180 degrees. The sum of their measures is 180 degrees. They have three sides. 3 minus 2 is 1, and 1 times 180 degrees is 180 degrees. So our different shapes will have different sums of their interior angles there. We do the same thing with quadrilaterals. It's going to be rectangles, squares, lots of different types of quadrilaterals. We say 4 minus 2 is 2 times 180 degrees would be 360 degrees. So the sum of the measures of the interior angles for quadrilateral would be 360 degrees. And then so on and so forth. The more degrees or the more sides that you have, the larger the sum of your angle measurements will be. So for example, we want to find the sum of the measures of the angles of a hexagon. So our hexagon has six sides in this case. This is our hexagon here. So we're going to find the sum of those angle measurements. So starting off with identifying our formula, n minus 2 times 180 degrees, where n is the number of sides of the shape. If we look at our hexagon, we can either follow the chart that we had before. We can just count the sides. 1, 2, 3, 4, 5, 6. So our hexagon has six sides. This in our case means that n is 6. Hexagon has six sides, n is 6. So we plug 6 in for n into our formula. 6 minus 2 times 180 degrees gives us 4 times 180 degrees. And that answer is 720 degrees. So the sum of the measures of the angles of our hexagon is 720 degrees. We can do the same thing for an icosagon. Remember, an icosagon was the 20-sided polygon. This is very similar to a circle at this point. So the more sides your polygon has, the more circular it will end up looking. So in this case, this is an icosagon. This has 20 sides. very circular. So once again, our formula, the sum of measures is n minus 2 times 180 degrees. N is the number of sides of the shape. We already said that this was an icosagon, which has 20 sides. So n is, in this case, is 20. So plugging in 20 for n into our formula, we have 20 minus 2 times 180 degrees would be 18 times 180 degrees, giving us 3,240 degrees. So the sum of the measures of the angles in an icosagon would be 3,240 degrees. Quite a bit. A lot of angle measurement there. All right, so that's how you find the sum of the interior angle measurements for really any type of polygon. So moving on from there, we can talk and kind of focus a little bit on quadrilaterals. There we go. So just as there are special names for very specific triangles, there are special names for specific quadrilaterals as well. So a quadrilateral, remember, is a polygon with 4 sides. There's many different types of polygons with 4 sides. So starting with A, we have a trapezoid, has exactly 2 parallel sides. So our trapezoid here in this picture, we still have the 4 sides, but 2 of them are parallel. So in this case, for this trapezoid, that's the top and the bottom. They're parallel to each other. They follow along with each other while the other sides are not parallel. So that's what a trapezoid is. A parallelogram has opposite sides that are parallel and also equal in measure. So the opposite sides are parallel with each other and they are the same measurements. So we see they're kind of tilted here. Parallelogram is kind of like a slanted rectangle. Then we have a rectangle as a parallelogram with 4 right angles. So they're parallel, they have the same lengths, but they create right angles instead of these obtuse and acute angles like we have here. A rhombus is a parallelogram in which all the sides are all equal in length. So a rhombus is kind of like a slanted square. So each length here is all the same and they're parallel. And a square is a rhombus with 4 right angles. So each side is the exact same, but the angles they create are right angles instead of these acute and obtuse angles here. We have a little bit of a flow chart to kind of describe like the breakdown of quadrilaterals. So when we have quadrilaterals, we can separate them into 2 categories, parallelogram or trapezoid. Trapezoid is just by itself. There's no umbrella term. There's nothing underneath it. It's just a trapezoid. If you have a parallelogram can actually be classified as a rhombus or a rectangle. So either having all same equal sides or their sides are right angles. So kind of branching off into one of those. But then from rhombus and rectangle, they both connect again to be a square. So really a square is a rhombus. It's also a rectangle. It's a parallelogram, which is a quadrilateral. So a square can be categorized as really all of these things, where like a rhombus is a parallelogram that's a quadrilateral, or a rectangle is a parallelogram that's a quadrilateral. But your square is all of them, all of those things. Your square satisfies the requirements for each one of these different shapes. So it can be classified as many things. So those are the different types of quadrilaterals. There's quite a few here. So there's at least 5 types of quadrilaterals that we can kind of break this down into. And since it's still just a polygon with 4 sides, every single one of these shapes would have the interior angle measurements of 360 degrees. So, all right, let's go ahead and move on. So we're going to move on to perimeter. So we say the perimeter of a polygon is the sum of the lengths of the sides. So your perimeter can change with different types of shapes that you have. So in this case, we see the perimeter of a triangle with sides A, B, and C would just be perimeter was A plus B plus C. So your perimeter is just the length measurement of each side of your shape. And sometimes they have very specific formulas, which we'll kind of see here soon. Your perimeter, if you would like to think about it, like the area or the surface area of your shape is essentially like your shape all filled in. It's everything inside. Perimeter is like you take a piece of string and measure the outsides of your shape. It's just the outside. It doesn't take into consideration anything inside, definitely nothing 3D. So your perimeter is similar in that way of like taking a string and measuring each and every side. And so you see how long it is in total. So anyhow, your perimeter is just the sum of the side lengths. So perimeter for a square, we know a square, every side length is the same. So it'd be S plus S plus S plus S, which is the same thing as just saying 4 times S. They're all the same. There's 4 of them, so it's 4 times whatever that length is. For a rectangle with different lengths and widths, we would say our rectangle would be length plus width plus length plus width, or length plus length, width plus width, anything along those lines. So there'd be 2 lengths plus 2 widths. So we can say 2 times length plus 2 times width. So these are the perimeters of our different shapes here. So for an example, we're going to figure out an average football field is 360 feet in length and 160 feet in width. We want to know what's the perimeter of an average football field. So we have our football field here, which is kind of drawn out for us. So we're saying that it's 360 feet long and 160 feet wide. So we're going to find the perimeter of the whole thing. So we know it's a rectangle. So our perimeter for our rectangle would be perimeter equals 2 times the length plus 2 times the width. We know what the length is and we know what the width is. So we can go ahead and we can plug those in. Length is 360, width is 160. So plugging those in, we get our perimeter would be 2 times 360 plus 2 times 160. That comes out to 720 plus 320, which is 1,040 feet. So the perimeter of our football field, or the average football field in this case, is 1,040 feet. So that would be how long it is if you took one, in this case, probably like a rope. If you took a rope and you went around the entire football field, you cut that rope and you measured the length of the rope, that would be what your perimeter is. So it's just the sum of the side lengths. So, all right. Now for our last example here, we have the length of each outside wall of the pentagon is 921 feet. So the government building, the Pentagon, that's what we're talking about, the picture here. So we're going to suppose that a sentry must walk the outside wall 6 times during their 4-hour shift. How many miles do they have to walk in one shift? So we have a little bit of conversion in this case, as well as finding perimeter. We're saying that if this person is just walking along the edge, we're finding the length of the perimeter in that case. So it's 921 feet for every outside wall. There's 5 of them. We can even count 1, 2, 3, 4, 5. So there's 5 outside walls altogether. So we would have that length times 5 there. And then our sentry here is going to walk that 6 times. We're going to convert that into how many miles that they actually will walk. So we'll do a little bit of converting between feet and miles. So, all right, let's go ahead and do this one together. All right, so for our example, we have our pentagon. I drew it out already. So we see we have the pentagon. We're going to assume that every side length is the same. So they're all going to be equal. And there's 5 of them. So we know that each one of these sides here, these lengths, are 921 feet. So they're each going to be 921 feet. We'll draw a little line in between all of these to indicate that these are all the same. They're all equal. So we can start off by just figuring out what is the perimeter of our pentagon in general. In feet, just what is it? So in our case, the perimeter of our pentagon would be 5 times the number of feet that it is. So we can call this, S for the side or something. So we have our value of our side here. So the perimeter would be 500 times S, which would be 5 times 921. And this answer is going to be in feet, which will be 4,605 feet. So the perimeter of our pentagon is 4,605 feet. Now we're told that our century walks this 6 times. Oh, this is misspelled. It should be 6 times here. This is 6 times during the 4-hour shift that they have. So they're walking this 6 times around. So they're walking this 4,605 feet 6 times. So we want to find the total, total amount that they've kind of walked here. So our century will walk the perimeter 6 times for a total length of 6 times perimeter, which will be 6 times 4,605 feet, which will give us 27,630 feet. So the century in this case is walking a total length of 27,630 feet. But remember, we want this in miles, so we need to convert this number into miles. So we want to remember our conversion tactics that we used a couple sections ago, converting our value here into miles. So when we do our conversion, remember we start with the value that we have. So this is 27,630 feet, and this just gets divided by 1. When we convert to miles, we know that we have feet, we're converting to miles. So when we multiply, this ratio should have feet in the denominator, so we cancel out the feet. So we can convert straight into miles. We can think of, okay, how many feet are in 1 mile? So in 1 mile, there is 5,280 feet. So you can go ahead, our feet cancel out, we're left with miles, which is what we wanted. We multiply straight across, we end up getting 27,630 over 5,280. This answer here is in miles. Go ahead, go to our calculator. Let's go with 2 decimal places. This should end up giving us 5.23 miles. So that century in a day walks 5.23 miles in a day, and they're in their 4-hour shift. That's how many miles that they end up walking. So that century is definitely getting their steps in. So, all right, that wraps up that example. So let's go ahead and go back over to our lecture. And that wraps up section 9.3. So in section 9.3, we learned how to find the sum of angle measures of a polygon, how to find the angle measures of a regular polygon, and how to find the perimeter of a polygon. So, all right, that wraps up our section, and I'll see you in the next one.